Welcome to Introduction to Maya series. I am your instructor Rohan Page. In this video, we will understand the workflow of creating oil smoke in Maya. What will be our workflow? We will first of all create a basic scene. Then we will use 3D container and emitter to have fluid emission in our scene. Then with the help of attributes of fluid, we will create a required effect. Let's start with the session. Let us create an example of a oil smoke, you can say, with the help of fluid effect. To do so, first I'll go to Polygon Shelf, create one plane. It will work as a grid, or you can say a floor. Create any kind of a basic object from where you want to emit a fluid. So I'll just create one sphere. Place it on the floor from where you want to emit that fluid. Just rename it as Emission Object. This as a floor. I'll select both of them, just freeze the transformations. Go to Fluid Effect, create an empty 3D container. Now place it according to our requirement. I'll make sure that the emission object is within this container. Attribute editor. Now the size of the container, we need to start with how we can change the size of the container and all, but before that we'll have an emitter. I want to emit this fluid from this object, so select your container, shift select your emission object, then go to fluid effect, add edit content, emit from object. Make sure before you play, your playback speed is every frame with real-time maximum speed. Now I'll increase the number of frames to check it out how it is working out. Now this is how the fluid is getting emitted. Now in the last session we have seen how we can increase the resolution of fluid and all based on the resolution. So select this respective container. Now start editing its values according to our requirement. Starting with the resolution, increase this resolution value to see fluid in a better way with a good resolution. We will keep it for 35 right now. Later on you can increase it. Okay, now the fluid, we can see it is getting emitted like this. Before you move further, make sure that you will save the scene. Now about size, you can increase the size according to your requirement. I would like to extend this container in x-axis like around 25, in z 25, in x I'll reduce it to around 15, and in y-axis I would like to extend in y-axis around 15. Okay, now the fluid is getting emitted. Start editing its values. Right now I'll go to, first of all, uh, emitter attribute. In emitter I will increase this density emission from the emitter. Right now that is not that much dense to create a oil smoke which is really dense. So we need to increase this fluid emission density. Let us increase it to around 10 to 15, around 10. Just check it out how it affects the overall emission. If you want more dense, you can increase it to 15. Right. I don't want to I don't want this emitter to emit heat or fuel. We will just make sure that it will emit only density, and we will give it a look of a smoke, and we will have another emitter to emit heat and fuel. So go to heat method, no emission, and fuel also no emission. So play now. So this is how density is getting emitted. Now go back to your container attributes. Have temperature as a dynamic grid and fuel as a dynamic grid, as we will require it as we are creating oil smoke. You can say because of a fire the smoke is coming out of the object. Now go to next rollout, that is content details, starting with density. Now density scale, we have already increased the value of density emission, so we need not to increase it, but still if you want to, you can increase it till 1, because that is good enough density which can get emitted from that respective object. Now about buoyancy, right now the overall speed of the emission, how the fluid is going in upward direction is good. For that I will have to use a little bit of damping. So go to dynamic simulation option, there we have damping value to create a little bit of uh, resistance. If I'll add a value of 0.5, let us see how it affects. So now that fluid is going a little bit very slowly. When the value was 0, you can observe how the fluid was moving in upward direction very fast. So as soon as you increase the damping value, it will create a little bit of resistance, due to which the fluid will go slowly in upward direction. I need not to work with the buoyancy, as I don't want to make it look light in a weight. Dissipation and diffusion we will work after creating an effect according to our requirement. The next thing is about velocity. Now the fluid emission is very not so random, or it's not having any kind of swirl or anything in it. So go to velocity, in content details, go to velocity rollout and increase this velocity swirl to around 5, and add a little bit of noise around 2. Now you can have more velocity swirl around 10. This is how it is getting emitted. Just try to increase little bit of resolution from 35 to around 60. Okay. After velocity, we will work on turbulence also. So I add randomness with the help of adding turbulence around strength around 3, and frequency is nothing but the repetition of that randomness. So I'll add it to 0.5 and just see how it affects. 3 is it is making that fluid very random, so I'll make it to 1. Increase the velocity swirl to around 15. Damping is too much, so I'll just reduce the value of damp to around 0.1. Okay, we will work with the temperature value and fuel value as soon as we will add other emitter. So before that, we'll go to shading rollout. The transparency, you can, if I'll reduce it, it is getting more opaque, whereas increasing it, it is going to make it a little bit like this. So not so much, I am not changing that value that much. So this much is this much display of the fluid is okay for me. Change the color, I'll make it with dark gray color, a little bit of a smoke. In opacity graph, as we have discussed in earlier version, if I'll click on this point at starting point and reduce it, you can see that how it is going to affect the outer area of my fluid and how this is going to affect inner area. So I'll just move it a little bit over here, make it dense towards the center, while in outerward I am reducing it like this. Make it smooth. Go to shading quality. The value is 1, need not to change it. Go to lighting and turn on its self shadow so that it will not look flat. Now you can see how we can see this respective smoke. Now you can work with the shadow quality, increase the shadow opacity to 1, so we can have good amount of shadow over there. Change the light color to a little bit light yellow color. You can play around these values to change the direction of the light. So hold control middle mouse and drag. You can check it out how it is going to affect your shadow area. Okay, this is okay for me. Now I want to emit heat and fuel in this respective smoke, or you can see in this respective fluid container. So I'll select it. We'll create another emitter which will not emit the density of the fluid, but also it will emit the heat and fuel. So we'll go to go to fluid effect, add edit content, emitter, and change the emitter type from omni to volume. Just place it near the object. And we need to change the shape of that volume. I'll just go to channel box. We have an option like volume shape. I'll change it to sphere. Just reduce the scale. Make sure that you will remove this density method from emitter attribute. Density no emission. I don't want this emitter to emit any kind of fluid, but heat and fuel should be emitted. So now just play it. There is no as such any kind of difference in it. So increase the heat emission around 10 and fuel emission around 10. Will increase the heat around 15, and let us see how it is affecting it. You can see a little bit of change is happening over there. I'll just increase the overall resolution to 100. It will slow down eventually your overall simulation. Now we need to work with the values of temperature, fuel, overall buoyancy of the temperature and all. So select the container, go to the option of content details. In it we have a temperature where I'll increase the temperature. If you'll increase the temperature scale, it is creating more temperature within the fluid. I'll just have it to 1 right now. Change need not to work with the buoyancy. If you want to increase, you can increase it, but right now I don't want to. Now I want this dissipation should happen with the temperature. After few units it should disappear. So I'll give 1.5, 0.5 dissipation for the temperature. Just try working with the values. Now I'll go to fuel, increase the fuel scale around 4, and reaction speed should be 0.5 or 0.3. Just check it out how it behaves. If overall simulation is slower down, decrease the value. Light release value in fuel, make it 1. If I'll make it 5, you can see it's creating a white color. You can change the color over here. I'll use the value of 1 only. In shading I'll go around light color. This is over here. I don't want to emit the white color or something like that. I'll use this dark color only. White. Change incandescence map. It is nothing but the light within the fluid. You can increase the temperature scale now. Go back to temperature, increase the scale to 3. Okay, now as you know, over here the fluid is moving in a very straight way, so we need to have a push to this direction. I want to have a push to this fluid in Z direction. So for that you need to select the container, go to field. There we have an option of air. I'll apply a air field. Go to its attribute, check it out in which direction fluid is getting emitted. It is getting emitted, air is working in y axis, so I'll just make it 0. I want it in z axis, so mention value in z1. Play. Not affecting fluid that much, so select the air field, go to channel box. There we have an option of magnitude, which is nothing but the strength, overall strength of your fluid. So I'll increase it to around 10 and check it out how it is affecting. Increase the maximum distance. If the maximum distance value is 20, which means that this field is going to affect the fluid which is within the area of 20 units. So I'll just increase this to around 100 units and let us see how it is affecting. Having a pretty much push. I'll increase it to around 25 and have a look. Okay, the damping is too much, so I need to work on that. Reduce it to 0.03 or 0.2. Yes, now it is good. We need to reduce overall turbulence, and velocities will around 10, and reduce the turbulence train to 0.2. Let's check it out how it affects the overall fluid. Now it's good. Increase the density scale to 1.5. You can play around the value of this field, magnitude around 40. You can increase the select that emitter, first emitter, from where we were emitting density per voxel value around 15. I'll increase it to 25. Let us see how it is affecting the overall simulation. It will emit more dense fluid. Okay, now just go back to opacity graph. Check it out how we can change the overall look of the fluid. Now this is okay. Now to see it in a proper simulation speed, and also I don't want this fluid to go and hit the all top portion of the container over here, so you can add little bit of dissipation. So I'll just select it, go to attribute editor. In density we can have dissipation around 0.5. Let us check how it disappear, or make it add a decay to fluid. This much decay is okay, right? So it's time for us to see how it looks. Just take a render. For that, what we'll do is we'll add one more light. Use a directional light, press 7 on your keyboard. I'll go to mental ray. With indirect lighting, I'll turn on final gather with 300 accuracy, and we'll go back to camera, select camera, attribute editor, go to its environment option where I'll change the background color little bit to white, and take a render. We need more temperature in this fluid, so I'll just select the second emitter where I'll emit heat around 35, fuel around 20. I'll select the container, increase the temperature scale, and increase the overall buoyancy of the temperature around 8, and increase the temperature scale around 8. Just play the simulation. Okay, I'll just reduce little bit buoyancy to 3 again. Temperature scale to 5. Okay, you can make the color of smoke more dark. For that purpose, I'll go back to container shading details. In it, I'll use a little bit of dark color also. Increase the shadow quality to around 3. Right. Now select the container and increase for the final to see final simulation. Increase the base resolution value to 150, and in dynamics, over there in dynamic simulation, turn on high detail solve to all grids. It will take time. Let it emit a more amount of fluid, and then we'll see the render how it looks. You increasing the resolution, you can see how much randomness now we can see while having a good amount of resolution. I'll just stop the simulation, take a render. Now you can see the actual kind of smoke with a good amount of resolution over here. Now this is how the final output of the smoke appears. So if you want to see the Playblast, you can definitely see with the Playblast, or you can take a render of it. I'll just show you how it looks when you will render it with the help of render setting. Uh, Now let us take a Playblast and then we will see how we can start rendering it. So for Playblast, you can just first of all save the scene, right click. I want to save the Playblast with quality 100. Save the Playblast on desktop. Oil smoke. Now you can see how after Playblast, this is what the speed of this smoke is. And you can also render this respective scene, and later on you can convert it into a video file also. So let me tell you what can be the setting if you want to render it. If you want to render it, you just need to go to render setup. If you want, you can go to common tab. If you want that output to be, make sure your renderable camera is perspective. If you have created any other camera, you can choose that. I'll choose the preset. You can have full HD, half HD output. It's up to you. Right now I would like to use half HD, or you can use this 540 also. It's up to you. Now in quality tab, I would like to use legacy sampling, custom sampling with minimum level, minimum sample 1, maximum sample 4. Use Gauss filter. You can choose Michel also with filter size 4. Final gather 500. Just take a render and check it out how much time it is taking for render. So as you can see that it is taking around 1 minute 19 seconds for one frame render. According to the number of frames, it may take around 200 minutes or around 300 minutes to take a render of a whole sequence. So you can uh, render it with the help of you just need to go to rendering, render, and you can turn on batch render and it will start rendering it. But before that, make sure that in common tab you will use image format as targa sequence and frame extension as name.hash.ext. So the name of the file, frame number, and the extension, that is targa, will appear when it will save the image. So if you don't want to render it in mental ray, as it is going to take a lot of time, you can just check it out with a software render also, where you can go to this Maya quality tab where you can use production quality and just take a and change the filter type to Gaussian filter. Take a render how much time it is taking for Maya software, and as you can see it is taking less amount of time for Maya software. Now you can just select this light. If you want, you can go to attribute editor. As ray trace shadows will not be supported in mental ray, so you can turn it off and use depth map shadow with the resolution of 1024 and check a render. Okay, otherwise you can have more lights if you want more amount of uh, brightness in your scene. It is taking around 5 seconds, so it is not that much time, so we can have a render with Maya software also. It is going to save you a lot of time. So I'll just, to start the render, make sure that you'll go to file, set a project. As we haven't made any project, you can file, go to project window, create a new project, oil smoke, and I want to have this folder at desktop, so I'll save it. And then you need to set the project oil smoke and then start rendering your scene with the help of batch render. I'll come back soon as we will complete all the batch render. You can see that you can have a look around in script editor. As soon as it will start render, it will start rendering each and every frame. So let it happen and we will see after render how we can generate a video output of that targa image. After completing your rendering sequence, then you will get an message in script editor that is rendering is completed. You can see maya render log.txt for information. Now as we know that we have set a project before starting a batch render, so to find out where your images got saved, you need to go to start, wherever you have created that folder. I have created it on desktop. Go to that project folder. In project folder we have a folder called as images, where all your render data is saved. Now how we can see the overall animation which is happening, you just copy this overall path and with the help of run, or else from start you can type fcheck, which is a image sequence player of Maya. You can click over here. Now go to file option, open animation. You can paste your path over there, say open, choose first image and then open. So it will first of all play all the image sequence in that respective uh, player, fcheck player. Now this is how your final output will look after render. Let us see what we have learned in this video. what we learned in this video. We have seen that how to use emit from object so that we can emit fluid from the selected object. We have seen how to use temperature, fuel, heat and shading options to get the effect of oil smoke. We have seen that how we can use render setting for final output, in which we have seen that we need to use name.hash.ext frame extension for render. Then we need to use targa file format for rendering an image sequence, and always choose high quality output for rendering. For any query, you can follow me on Facebook. You can write me an email on rohan.pageanimator@gmail.com. You can subscribe to my YouTube channel, or you can follow my classroom with using this code. Thank you.